Jai to all of you. My name is Dr. Ritish Kumar and going to give a lecture on the topic of communication system, modulation and needs of modulation. So, uh, I'm an assistant professor in the Department of Electronics and Communication Engineering at Ajay Garg Engineering College, Ghaziabad. So, this is the syllabus of the university, this is the syllabus of university, uh, which is categorized in unit number from unit number 1 to unit number 5, and the topic which I will cover in this lecture will lie in the unit number 1, that is the needs of modulation, or what is the modulation and advantage of the modulations. So these are the recommended books, and I will prefer the books. First book, that is Simon Hagen, Communication System, and Tom and Schilling. The title of the book is Principle of Communication System. Let's begin the topic. What is the communication? Communication is simply the act of transferring the information from one place to another. The communication is exchange the idea, information and knowledge by two or more persons. So basically this is a basic communication system block diagram, which consists of various blocks such as information source, transmitter, channel, receiver and destination. So so in this section we can say this is the part of the transmitter side, and this is the section of at the receiver side. So we can say whatever we do at the transmitter side, just do the opposite or complementary at the receiver side. Actually we are doing the modulation process at the transmitter side, so we have to do the demodulation process at the receiver side. So whenever you transmitting the information from source to destination, there we have a kind of channel. So in the channel there are we have a another kind of signal, that is the noise source and noise signal, which is indeterministic by nature. So we don't know the nature of the noise, so it will definitely affect the information. So so first we need to talk about what kind of channel we have. Two kind of channel we have. The first one is the wired channel, and second one is the wireless channel. So wired means there is a physical connection between the transmitter to the receiver, and wireless means there is no physical connection in between the transmitter to the receiver. That means free space is the channel through which information exchange can take place in the case of wireless media. So in wireless media, we can say the channel is free space. So one by one we can understand what is the information source. As name suggested, the information source, it consists the information, that is the message which has some kind of main information, that is the like human voice, picture and data, music, etc. So this is a kind of actual signal, and this is the this is the transmitter side. Then we have to do the modulation process. That means this is a kind of low frequency signal, by which low frequency signal, and by the technique of modulation process we can convert this low frequency signal into the high frequency signal. Then before transmitting the modulated signal, we need to convert this electrical signal, we need to convert this physical signal into the electrical signal, so that information can transmit through wired or wireless channel. In case of wireless channel, we need to have electromagnetic waves, right? So after converting the signal in the electrical form, we can transmit the information from the channel, and at the receiver side we need to do the opposite operation of modulation, that is the remodulation process. Remodulation process is a process by which we can extract the main information from the modulated signal, that is the message signal. So after demodulation process, at last we can deliver the message signal to the destination. So let's need to discuss what should be the need of electromagnetic wave, because in the wireless communication system there is no physical connection between the transmitter to the receiver. Then we have to use a device, that is antenna. Antenna is a kind of device that converts electrical signal into the electromagnetic waves. So at the transmitter side we need to use a device, that is antenna, which converts electrical signal into the electromagnetic waves, and that electromagnetic waves is transmitted through a free space channel and it comes towards the receiver side, and again we need to convert this electromagnetic wave with in electrical signal with the help of receiver antenna. So in the case of wireless communication system, we need to attach an antenna device so that information exchange can take place in between transmitter to receiver. So I hope this is a basic block diagram you can understand by looking the different kind of different sections. Right. Next is the this is the explanation of the basic block diagram that I had discussed in the last slide. That is, what is the information source? Already we had discussed. Transmitter already we have discussed, and the channel is also we had discussed. It can have a wired and wireless. Now the noise. Noise is a kind of signal, or we can say it is an undesired signal present in the main signal, and this happens or this occurs during the transmission of information from source to destination, and in the channel a kind of noise is added. So noise is play a vital role to have the distortion in the main signal. So at last we need to focus the parameter, that is SNR. SNR stands for signal to noise ratio. That means it is the ratio of signal power to the noise power. So what should be the value, or what should be the range of SNR to have a better communication in between transmitter to receiver? The signal power should be as high as possible and noise strength should be as low as possible. So at last we can say SNR should be as high as possible to have a better reception of the main signal. So our main target to have a better SNR, or to have a increased value in the SNR, we need to decrease the noise strength by any technique, and most of the researchers are going in this field to reduce the noise by any technique so that we can have a better SNR at the receiver side. So this is we can say this is a kind of research topic to improve the SNR by increasing the signal strength or by reducing the noise strength as well. So this is a basic communication system that we need to, or we have to understand before starting the modulation process. So some basic terminology we have in the communication system. The first one is the baseband. What is the baseband signal, broadband signal, modulation, demodulation, modulating signal, carrier signal, and modulated signal. So baseband signal is nothing but a kind of main message signal, or we can say this is a kind of modulating signal. Other name is baseband signal is message signal, modulating signal, and main information signal as well. So modulation is the process by which we can convert a low frequency signal into the high frequency signal, right? Or we can say with the help of modulation we can transmit a signal, information signal a very long distance, right? So what is the demodulation? Demodulation is the complementary by nature of modulation. That means we need modulation is the process to extract the main information signal from the modulated signal, or in other words, to extract the modulating or message signal from the modulated signal is called a demodulation process. Right? And my message signal I had already discussed. Message signal is nothing but a kind of baseband signal, and modulating signal we can also say a message signal as well. This is a carrier signal. Carrier signal is a high frequency signal through which we can convert low frequency signal to the high frequency signal. With the help of carrier signal, we can do the modulation process. Modulated signal, that is the signal after doing the modulation process, we have received a kind of high frequency signal, that is the modulated signal, we can say. So there is a big difference between modulated signal and modulating signal. Modulating signal is a message signal, and modulated signal is a modulated signal is a high frequency signal where the carrier is superimposed to the message signal, right? These are the basic terminology we need to understand in the communication system. So let's begin with the modulation and needs of modulation. So what is the modulation? Then after we'll discuss the needs of modulation. So as I discussed in the last slide, modulation is the process by which a low frequency signal is converted into a high frequency signal, or in other words we can say the baseband signal can be converted into the passband signal as well. So we have different kinds of modulations depending on the nature of the signal. If we have a different analog signal and digital signal in categorized form, so we have analog modulation technique and digital modulation technique. Then that modulation techniques we'll discuss in the further lectures. So first we need to understand what is the needs of modulation. I hope the modulation process is clear to all of you. So there are various advantages or needs of modulation. The first and the biggest advantage is reduces the height of the antenna and increase the range of communication, avoids mixing of signal, allows multiplexing of signals. Apart from these advantages, the last one is improves the quality of the reception or quality improves the quality of the received signal as well, we can say. So all these advantages we will discuss in detail one by one in the next slide. So reduces the height of the antenna. How we can say the height of the antenna can be reduced by using the modulation process. As we know, with the help of modulation process, we can convert a low frequency signal into the high frequency signal, and we know that the antenna's height or antenna size always depends on the wavelength of the signal. And wavelength, if I talk the dipole antenna, I said dipole antenna. So dipole antenna is nothing but a lambda by 2 antenna, right? So the length of the antenna is depend on the wavelength of the signal. So here if you increase the length of if you increase the frequency, as we know, lambda is equal to C by F. So we can say lambda is inversely proportional to the frequency. So if you increase the frequency, then lambda will become decrease, right? So if lambda is decreased, so electrical size, electrical length of the dipole antenna will decrease, right? So in generally we can say, in general statement, if you increase the frequency by the modulation process, the wavelength will decrease, and if the wavelength is decreased, the size of the antenna is automatically reduced. Here I have taken a one example for the lambda by 4 antenna, that is monopole antenna, and you can see here I have considered the frequency, two frequencies. The first one is the 2 kilohertz and second one is the 2 megahertz. 2 kilohertz is the low frequency region, and the f is equal to 2 megahertz is the high frequency region. So here you can see by calculation by taking the frequency 2 kilohertz, we have the antenna length is 37.5 kilometer, which is practically impossible to fix the antenna at particular location. Yeah, to fabricate at the antenna so much length, right? But if you increase the frequency from 2 kilohertz to 2 megahertz by modulation process, then this height will become reduced from 37.5 kilometer to 37.5 meter. Here kilometer and here 37.5 meter, which can be easily constructed. So this is the biggest advantage of the modulation process, by which we can reduce the height of the antenna. Next is the increases the range of communication. So at low frequency, radiation is poor and signal gets highly attenuated. Therefore, baseband signal cannot be transmitted directly over the long distance. So by the modulation process, we can increase the frequency, and due to the increase in the frequency value, so the communication distance will become increased. Avoid mixing of signals. So here here you can see we have three signals: signal 1, signal 2 and signal 3, and all are the audio signals. And if without modulation process, it cannot be possible to avoid the mixing of signal. So by modulation process, we can translate these audio signal at different carrier frequency. Here we have considered 100 kilohertz carrier frequency, 200 kilohertz, 300 kilohertz. So here signal 1 is translated at 100 kilohertz, signal 2 is translated at 200 kilohertz, and signal 3 is translated to 300 kilohertz. So by considering different carrier frequency in the modulation process, we can avoid the mixing of the signal. So modulation has to avoid the mixing of signal. Next, allows the multiplexing of signal. Here you can, what is the multiplexing? Multiplexing is a process by which a multiple signals can be communicated, can be transferred through a single channel with the help of modulation process. So similar trends we can do here. Here we have a different. Here we have three signals, and here we are doing the modulation process for different carrier frequency. Here the signal 1 is modulated by at frequency, carrier frequency f1, and second one f2, and third one is the f3. So with the help of different carrier frequencies used here, we can transmit a multiple signal over a single channel. So this is the advantage of doing modulation of doing modulation process, and with the help of modulation process multiplexing can be possible. At last, improve the quality of reception can also be possible with the help of modulation process. So the effect of noise can be reduced. So this is the electromagnetic wave spectrum. So here we have drawn a spectrum of EM waves. So this is a TV and radio wave, microwave, visible, X-rays, and gamma rays. This is the frequency range we have drawn over a scale. Microwaves have different kind of band, L, S, C, X, K, U, K, K. These are the bands of microwave bands we have. So these are this table specify the application of different bands. Here you can see the main is a low frequency is used for navigation, and medium frequency is used for AM broadcast. High frequency is for telephone and telegraph, and very high frequency is used for FM broadcast, and ultra high frequency is used for satellite and TV. These are the application for different bands that I have mentioned in the table. So these are the bands name according to the IEEE, and these are the different kind of modulations we have for analog communication. The first one is the amplitude modulation, second one frequency modulation, and phase modulation. So what is the amplitude modulation? So amplitude modulation is nothing but the amplitude of the carrier signal is varied in accordance with the instantaneous value of the message signal while keeping frequency and phase constant is called as amplitude modulation. And in the case of frequency modulation, the frequency of the frequency of carrier signal is varied in accordance with the instantaneous value of message signal while keeping the amplitude and phase constant. In the case of phase modulation, the phase of the carrier signals is varied in accordance with the instantaneous value of message signal is called phase modulation while keeping amplitude is constant. These are the basic definition that we need to understand of the modulations. So these are the different analog kind of modulation. So I hope the topic of basic communication system and modulation and needs of modulations is clear to all of you. Thank you.